Right, there we go, guys. That is the new chapter that we're doing. Now we're going to work with geometry of straight lines and then also geometry of triangles, okay, over the next week or so. The first thing that we're going to be doing today is just angles on straight lines. All right, so that will be like a cloud heading or a bubble heading. Okay, now there are four things actually that we're going to learn just about angles that are lying on straight lines. So the first thing is angles on a straight line, which does look just like the heading, I know, but we are going to talk about other types of angles with regards to straight lines. So this is just the first one. So angles on a straight line. Right, now you guys are saying that you are familiar with this. If we have a diagram like this, so you can just copy it down. We have a straight line over there. And then it doesn't really matter how these angles look, but we're just going to kind of draw some more straight lines coming off of that first one. All right, we'll call this point, where all of those angles are coming from, we'll call that point B. And then we are going to label these angles as 1, 2, and 3. All right, but I also want us just to label this end of this line with an A. All right, that end over there, we're going to call C and D and then E, because I do want us to practice naming our angles. That's going to be very important going forward. Okay, now guys, the rule that we have here is that all angles that lie on a straight line, so if we're looking at this diagram here, do we agree that we have 3 angles that all 3 of them lie on the straight line? All right, now the rule is that these 3 angles, if we add them together, will add up to 180 degrees. Okay, now if you have your 1 and your 2 and your 3 over there, the naming is actually quite simple. You can just call this angle B1. That one is angle B2. That one is angle B3. Okay, they're not telling you that this angle is 1 degree and that angle is 2 degrees and that angle is 3 degrees. Okay, if they were saying that, they would have to put the degree symbol next to the actual number. All right, so these numbers that they're putting here are just to help you with naming them. All right, so we're going to use that naming convention. We're going to write B1. Okay, so you write the B, the 1 is as a subscript. All right, so it's not next to the B, it's kind of at the bottom of it. And then you have to put that little cuppy thing to show that it's an angle. All right, so angle B1 plus B2 plus B3 must add up to 180 degrees. Okay, that is a rule that you need to remember and that you need to be able to apply. All right, now we're going to practice applying this rule. We're just writing all of them down first. Now, guys, it doesn't have to be 3 angles always, all right? It could have only been 2, maybe. If there were only 2 angles here, the sum of the 2 would still be 180. Even if there were 10 angles on this one straight line, it would also be, all of them added together should equal 180. Okay, now I'm not sure how familiar you guys are with naming angles if the 1, 2, and 3 wasn't there or weren't there, all right? If those little numbers weren't there. What would we call this angle here? We can't now say that this is angle B because there are 4 angles at point B, all right? We have to be specific. Now, guys, do we notice that B1 actually lies between points A and C? All right, so that is how we're going to label this angle. We're going to say that this is angle ABC. All right, so the B is where the angle is. That one must go in the middle. And then on either side, you need to put the points that are on either side of this angle. All right, so we're going to write A, B, C. And then because B is where the angle is, that is what you put your angle symbol on top of. All right, we are going to practice this a lot still. All right, but I just want us to get used to it. Now the next one, B2, what would I call that angle? Angle CBD. Or you can also say DBC. All right, that order doesn't actually matter as long as the B is in the middle and the other two letters are on the sides. So let's call it CBD. All right, so plus CBD. The important thing is that the point where the angle actually is must be in the middle and the symbol must be on top of that. All right, and this one? Yes? Sure, this one is DBE. Right, is that fine? Or EBD if you wanted to, right? DBE. Now guys, from now on, when we are doing geometry, we always have to write a reason next to whatever statement we're making, next to whichever rule we're using. Okay, so that is something that you put in brackets next to the first statement. Now the reason for this, and this is all laid out in the CAPS document, I will post a page of all the reasons that you need to memorize. Now guys, if you don't put the reason, then you're not going to get a mark. Okay, and it goes like that all the way up until matric. So we do start kind of training you in grade 8 already to use the correct reasons. Okay, now the reason for this, whenever you are using the fact that these three angles must add up to 180, say for example, they've given you B1 and B3 and you need to figure out what B2 is, you're going to use that rule, but then your reason is, so let's write that, reason. And I'm going to put it in brackets because that is how you need to write it down. Okay, you have to put it in brackets. Angles on a straight line. Okay, like that. You can abbreviate angles, or it's not really abbreviate, you can use that symbol, all right? So it's like an angle symbol with a little H there, but then you have to write on a straight line. Every time you use it, you need to write that down. Okay. And that's also going to take practice, but we are going to practice it. All right, any questions on this one? We're all fine. Yes.
What is that talking about?
So that is just when you use this rule. So we are going to practice it still, but if you have to say find what angle B1 is, they've given you those two. And you're using the fact that all three of them together must add up to 180. Then next to that, you need to write this in brackets. Whatever, and then in brackets that. Yes, exactly, yeah. Okay, the next one is vertically opposite angles. All right, we're going to draw another diagram. Let's put the B here at the bottom. Okay, now vertically opposite angles, all right, this is another rule. Now the important thing is the only way for you to use this rule is if you have two straight lines that are cutting each other, all right, that are crossing. That's why we call it, it's almost like the X rule. Okay, it has to be an X. So guys, if this line BC was kind of, let me just do it, I'll erase it now. If it was going like that, for example, all right? Then we couldn't use vertically opposite angles because is that now a straight line from D to B to that point? No, it has to be a straight line. All right, so we are going to write that there at the top. Let me just erase this quickly. Okay. Okay, so when two straight lines cut, and what that rule is saying is actually that vertically opposite angles are going to be equal. So the two angles that are opposite each other will be equal. So if we're looking at B1, you can make a little thing there, B1 and B3. Those two angles will be equal. And guys, if you have a protractor, you can actually measure that. All right, that will always happen. Whenever you have two straight lines that are cutting, the two angles that are opposite each other will be equal. Yes, Eve? Yeah, so it's saying that this angle is B1 and that one is B2. But we are going to do the different namings now again as well. But guys, are there two other angles here that are opposite each other? B2 and B4 as well, hey? So now if you want to show that those two are equal, guys, you would have to use two little, what would you call those things? Loops, whatever. All right, and then here we go. All right, they sometimes use that on, let me actually move the one next to B2 so that it's a bit further out. They actually use this notation in questions. So that's why I want you guys to get used to it. All right, if they are using one thing in two angles, that means that those two are equal. And where they're using two, that means that those two would be equal. All right. Guys, like I said, you could use your protractor. You can check this, all right, if you want to, but it will always be the case. If you have two straight lines crossing or cutting each other, the opposite angles will always be equal. Yes. It's also in geometry. Yeah. All right, so we're going to write here that B1 is equal to B3. So guys, they might give you the value of B3. They might tell you that B3 is 100 degrees. Then you would have to say B1 is equal to 100 degrees. All right, that's how you would use this. So B1 is equal to B3 and B2 will be equal to B4. Now we're just going to practice our other way of naming angles, all right, in case the 1, 2, 3, 4 wasn't there or weren't there. So now B1, what would I call this angle? Because the angle is at B, that must be in the middle, and it is in between which two letters? A and C. Good. So it's going to be ABC is equal to B3 is, well, not necessarily, but the name of B3, the other name would be DBE. All right, and if we have B2, what am I going to call B2? CBE, good. CBE. And then B4 is going to be ABD, right? Because the angle is at B, but it is between A and D. So ABD. Now the reason for this, guys, vert, op, angles equal, like that. Okay, you are allowed to use those abbreviations, vert, op, angles equal. Okay, the third one, angles around a point. So now I just want you guys to actually make a little point, and then we're just going to draw 3 lines kind of moving around that point. All right, it doesn't matter really how those lines look, as long as they are straight lines like that, going from the same point. Okay, now I'm going to use a different notation. This is also something that they often use, is that they'll use letters to represent the 3 angles. Do we agree that around this point we now have 1, 2, 3 angles, right? So let's call them X, Y, and Z. All right, I want you guys to get used to all the different notations that they can give you. So sometimes they just use variables, just letters. Instead of telling you what that point is and then putting a 1, 2, 3 there, they can use variables as well. Now guys, the rule here is that angles around a point, again, if you have your protractor, you can actually measure this. All right, if you measure angle X and then angle Y and then angle Z, and you add the 3 angles together, and again, it might be more than 3 angles, it might be less than 3. All right, if you add those 3 angles together, what do we think it will add up to? What kind of shape am I making here? Yes, Nicholas? 360 degrees. All right, that is the third rule, guys, that angles around a point will always add up to 360. So you can write it there. X plus Y plus Z will equal 360 degrees. Okay, now because I haven't written letters here on the ends of these lines, we can't actually name those angles anything else. Right, so the only naming that we can use there is using those variables. Now guys, the reason for this, there are actually 2 options. All right, the shorter one is revolution. So you can write that if you want. All right, because it's 1 revolution around the point, and that will be 360. Or you can write angles around a point. And you are allowed to abbreviate point to PT like that. Yeah, we're fine so far. I'm going to do one last one quickly, and then we're going to do a couple examples. Okay, the last one is perpendicular lines. And perpendicular lines are lines that meet at a 90-degree angle. All right, so I'll draw an example now. Now guys, I'm not sure if you've seen that symbol before, where it's like a little square, right? It doesn't have to be a perfect square, just kind of try and draw a little square there. Whenever you see that symbol, that is saying that that is a 90-degree angle. All right, so you can make a little arrow there. Oops. Make an arrow there to that little square. So guys, they won't ever write 90 degrees in like, not in words, but they won't actually write down 90 degrees. They will always use this symbol. Okay. Now guys, something to look out for also when we're doing geometry is that they always say at the top of the paper or the top of the example or exercise that the diagrams are not drawn to scale, all right? So unfortunately, you can't just look at a picture and think, oh, that looks like it's a 90-degree angle, so I'm going to say that it is, all right? You wouldn't be allowed to do that. Sometimes they even draw a picture so that it looks different from what it actually is to try and trick you guys. All right, so the only way to know if you have a 90-degree angle is if you actually see that little square. Now, guys, if we know that this angle is 90 degrees, do we agree that CD is a straight line? So what will this angle have to be? Remember, two angles on a straight line must add up to 180. So if that angle is 90, what is that angle going to be? Also 90. And what about this one here? 90. And this one at the bottom? 90. Now for this one, you could use angles on a straight line, working with that, or vertically opposite angles to get that bottom one is 90. All right, so let's write that down for all of these. So AED, we know is 90 already, but now we're going to say AEC is equal to 90 degrees. All right, and now this is a case where we would have to write our reason. So now we're going to say angles on a straight line. Okay, so basically you write the size of the angle and then you write almost which rule you used to get that value. All right, now we can fill it in with our different color pen or pencil or whatever. Oh, that's a very ugly square, but you get the idea. Right, then we said that for BED or DEB, we're also using angles on a straight line if we're working with that straight line, hey? So BED is also 90 degrees. All right, that's also angles on a straight line. So guys, was that the only reason that I could have used for getting that this angle is also 90? What other reason could I have used? Yes. Okay. Not yet, but eventually, yes, we could use revolution for the last one. This one here, if we know that that angle is 90, can't I use vertically opposite? Okay, so guys, that's also a thing. Once you've calculated other angles, you can actually use those other angles to get the next ones. All right, so angles on a straight line is perfect to get that angle, but you also could have used vertically opposite angles. So let's write that at the bottom, or you could have used this reason as well. So guys, in a taster exam, you only need to write down one reason. Okay, I'm just showing you that there would be multiple different ways of getting to the answers here. All right, and that is often the case with geometry. So now I'm going to fill in that one there. I'm just making it a bit bigger so that it doesn't cover my E. All right, now for the last one, we could use angles on a straight line. We could use vertically opposite angles, or like Monkey was saying, now we could use revolution. All right, because now we know that these four angles must add up to 360. So 360, and I already have 270 if I have that those three are 90 degrees. So then the difference would be 90. Okay, so for the last one, which is C or BEC, that one would also be equal to 90. Now we're going to write down all three possible reasons. Again, in a taster exam, you would only do one, all right? Or even in an exercise, you only need to do kind of the first thing that you see. But I just want you guys to remember that we can use different ones. So you would say angles on a straight line, or you would say vert op angles equal, or you could say revolution in this case. I'm not going to write the other option. Remember, for revolution, there is actually another one that you could write. You could also write angles around a point. Okay, is that fine, guys? But if you write angles on a straight line for all three of them, you will get full marks. Now, guys, please notice that even if you're using the same reason for all three of them, you need to write that reason 3 times. Okay, which is a bit of a pain, I know, but you have to make it clear, because if you are just leaving it out, say you thinking to yourself, oh, it's angles on a straight line, I already wrote it once, I don't have to write it again. How am I, the marker, going to know that you just forgot to write the reason, or you didn't know what the reason was, or must I now just think, oh, they knew it was the same reason? All right, you need to make it clear which reason you're using. Yes.
You use it, and you overwrite it if you want to. You overwrite angles around the point.
Yes, you can, yeah. So for revolution, you can use that other one, yeah. Okay, guys, let's do some actual, this was kind of an example, but let's do some more. So let's write examples. Okay, so calculate the value of x. I'm going to draw a little diagram now that I want you to copy as well. Okay, draw that picture, please.
We have to start to get the angle with that, and just draw the line.
No, just rolling in, it's fine. Okay, now guys, do we notice that these 3 angles that they've given us, that they all are on a straight line, right? Let's draw a little thing around the 3 of them. So what must those 3 angles equal together if I add them together? 180, all right? So I'm just going to write that on the outside of that kind of loop thing. So all 3 of those angles must equal 180. So guys, we need to figure out what x must be, so that 28 plus 53 plus that x value will give us 180. Now I just want to show you guys how they want you to write it down. All right. So we're going to write, let me do it in blue. X plus the other 2 angles, 28, and then plus 53 should equal 180 degrees. All right, are we fine with that? The 3 angles, if I add them together, should equal 180. Now, guys, this is now where you're going to put your reason. Okay, how do I know that they must equal 180? What is that rule? Angles on a straight line. Thank you. So whenever you use that, as soon as you use it, you need to write it down. Okay, so not only actually at your answer, because we have multiple steps here, you write it down as soon as you actually writing almost like the rule out. So guys, what do you think? How am I going to get what x is now?
You subtract 28, 53 from 180.
Yes, good. All right, guys, on this side, now I know we haven't done equations yet, all right? I'm not sure if you did equations in primary school. On this side, I have x and I'm adding 2 values to x to get 180. Now, if I want to figure out what x is, I'm actually going to have to subtract those two values from 180. All right, so x is going to equal 180 minus 28 and minus 53. All right, you'll see now when we actually get our answer that it does work. So now if you, you can type this into your calculator. They usually allow you to use a calculator for geometry stuff, okay, because it's working with big numbers. Or you could also just do this in your head if you want to. But the final answer is 99 degrees. Now guys, do me a favor, please. Quick, oh, never mind, I have my calculator here. Obviously, you could now again add this up in your head, but just quickly, let's, oh, what's going on here? One, also just do that. All right, let's quickly add these three values together and see if it works, if x is 99. 99 plus, what were my other two angles? 28 and 53. And there we do see that it is equal to 180. All right. And that's how you would do this, guys. This is literally what you would write down. You would get 3 marks for this question. You would get a mark for writing that line out. You would get a mark for your reason and then a mark for your answer. As you go into higher grades, sometimes they give you 1 mark only for the first statement plus the reason. All right, so in matric as well, I mark paper 2 matric finals, and you won't get a mark for that line, that step there. You will get 1 mark if you have this whole thing written out and your reason correct. Okay, meaning that if your reason isn't there, you don't get that mark at all. Right, which is why we start training you already with your reasons now. Okay, it's very, very important. Are there any questions on that one, guys? Fine. All right, number 2. Calculate the values of x, y, and z. And don't worry about how these lines look and how your angles look. You're just going to draw 2 straight lines that are crossing, and then we're going to fill some stuff in. So we're going to say that this first angle here is 56 degrees, and that is an X, and that is a Y, and that is a Z. Just add that there, what I've written in blue there. If they're saying in the question, calculate the values of X, Y, and Z, that is the order that they want you to find those values in, all right? Sometimes they give you a picture with a whole bunch of letters, all right, which we will get to later on. Then they'll say, do it in alphabetical order. Okay, but now because there are only 3, they've listed the 3. So you need to first find X and then Y and then Z. Okay, so you need to assume that it is in that order. So guys, do we agree that we have 2 straight lines that are cut? So what does that mean? X is going to be 56 because of vertically opposite angles. All right, X equals 56 degrees. Please guys, your answer also always needs to have the degree symbol. All right, if you look at the first question, every time I wrote a value, it had that degree symbol there. That's important. So X is 56, and how did we know that? Vert, op, angles equal. Make sure that every time you're using one of those rules, you are writing down the reason. Okay, now if you want, guys, you can use your pencil or different colored pen or whatever, and you can actually fill that value in on your picture. Now we need to find Y. That's the next one. Now what can I use? I want to hear from someone else. Someone else that hasn't spoken yet today. Joseph? What do you think? What can I use for y?
I'm not quite sure.
Look at that. Does that help?
I don't know. Sorry.
Did you it? Not 90, but what do these two angles add up to? 180. All right, do we see this? 56 and y, they lie on a straight line, so they should add up to 180 degrees. All right, so we can do a two-step thing if you want. You can say y plus 56 degrees should equal 180 degrees. And the reason for that is angles on a straight line and now to actually get what y is, I'm going to have to subtract that 56 from the 180. All right, so we're going to say y is equal to 180 minus 56. Right, and what is that if I work that out? What's 180 minus 50? 180 minus 50 is 130, and then we minus another 6 from that. That's 124. Good. Okay, so let's write that in. Yes.
You don't mind your reason with your answer, right?
Yeah. So we call this line the statement line. So this is just where you actually writing the fact. You know for a fact that y and 56 together should equal 180. Okay, so at that statement line, that's where you put your reason. Okay, guys, one last thing. We need to find z. Now we have three options again. All right, what is the quickest one? Like a one-step option. Yes, Nicholas? As y, yes. Okay, so vertically opposite angles. Because these two, we have two straight lines cutting, and these two angles are opposite each other. We say that z will also be equal to 124. Z equals 124 degrees, vert op angles equal. Or you could have done the same thing that we did to get y, all right? You could have worked there with angles on a straight line. You would have gotten the same answer. Or you could have worked there with angles on a straight line. Or we now have 4 angles around a point, right? We know the value of 3 of them. So if we want to find the fourth one, you could say 360 minus those 3 angles around a point. Okay, that would give you the same answer. But the quickest way would just be to do vertically opposite angles. Okay, guys, you're going to practice some of these for homework. So in your Platinum textbook, I will put it on the board now because I do need to just ask you to fill something in. Just write this down, exercise 12.1 on page 134. Okay, just write that down quickly so I can put it on the board. Platinum, yeah. Okay, now guys, this exercise has 3 parts to it. All right, 1 and 2 are on the one page, and then number 3 is on the next page. In number 1, they're saying here, write down the vertically opposite angles in these diagrams. All right, so they just want you to state which angle will be equal to which one because of vertically opposite angles. But guys, they haven't told you what those points are equal to. Hey, do we see that? They've just put 1, 2, 3, 4. Okay, but we do need to actually know what letter we are using. So can we all please take a pencil? Pencil, please, because in future years, other teachers might have other ideas. All right. Just label this point. Now you're going to have to just try and find a space somewhere. Just label it as A. I don't really know where to put it. All right, but just that point in the middle every time is A. Okay, see if you can find like a little space there. Use a pencil, please. Okay, so I'll do the first one with you guys just so that you can understand what they're actually asking. Here, which angles are vertically opposite? A1 and A2. So guys, they want you to write this. A1 is equal to A2. Perfect? Yes. Next ones, are there more angles that are vertically opposite in this diagram? A3 and A4. All right. Yeah, that's all you need to do for number one. In B, you're again going to look for vertically opposite angles. All right, there might be more than 2 pairs, just a hint. And then in C, you're going to do the same thing. All right. Then in number 2, they're saying in these diagrams, now I didn't actually write down this symbol. Maybe we must just quickly go back to the note quickly. This symbol here just means perpendicular. All right, we'll add it now. So if they're saying that AB is perpendicular to CD, that means that AB cuts CD at a 90-degree angle. All right, so let's quickly go back to the note. Sorry, guys, I forgot to add that. So if we're looking at our number 4 in that note, that is about perpendicular lines. Oh, where did I put that pen now? We have 2 lines here that have met or crossed or cut. Do we agree with that? We have AB and we have CD. All right, the name of that line would be AB. Do you guys remember when we did constructions? We put an A and a B and then we said that line was AB. So this one is AB and that one is CD. And guys, because they meet at a 90-degree angle, we say that they are perpendicular. So you can just write it underneath the diagram if you have space. So that is how you would write it like in maths terminology. All right, so instead of writing AB is perpendicular to CD, you would just use this symbol, AB. And do we see that that kind of looks like the situation that we have here? All right, we have like a 90-degree angle there, and then CD. Okay, so guys, in number 2, if they're telling you that AB is perpendicular to CD, they're telling you that you have a 90-degree angle there. All right. Same thing here. AB perpendicular to CD, those angles are also 90 degrees. All right, so that is also going to be 90. Now for number 3 is similar to the examples that we did now, where they're just saying determine the sides of the angles marked A to D in these diagrams. Remember to give reasons for every statement you make. So you need to find the value of A, you need to find the value of B, the value of C, and the value of D with your reason next to it. Okay. Yes.
What you do for 1C, because it's kind of missing a lot.
Yes, so for 1C, you're only going to write the ones that will actually be equal. All right, so not all of them will be equal there. Do you guys see what he's saying? You don't have, if this line went all the way through, right? Do we see that? This line here, if it went all the way through, if we had that kind of situation, I don't know, let me just see. There we go. If that was a line, then you would again have 3 pairs of vertically opposite angles that are equal. Okay, now you don't. So just write the ones that will be equal. Okay. That is a bit of an application question there, but see if you can do that one. Okay, grade 8. So that is your work for the rest of this lesson. You only have 8 minutes left, so you might have to finish some of it at home. All right. Also remember,